All right. Now we are going to look at the convolutional neural network. All right. When we working on computer vision, especially on images, okay. So CNN is very important. You can do neural network such as like what we have just now. We use pixel to put into the model. We treat input image as a pixel. If you got 28 by 28, you got 784 pixel to be inserted into the model. But that's this. You can work like that, but the practice normally we use a convolutional neural network instead of a neural network, and this one a little bit more sharp, accurate, and reasonable. So CNN basically for images. Okay, remember that it's designed for images only. You cannot use for other text data, just like financial history, thousand of customer with these features. We can't use the convolutional. We cannot use the convolutional neural network. So again, convolutional network is just for images basically, and it is a fundamental for YOLO. So the fundamental working of YOLO is CNN. Okay, without CNN, you can't go on YOLO. Okay, so this is YOLO. See, the YOLO is basically CNN. Okay, the concept of YOLO basically is CNN. So YOLO is this one. You only look once. So this the fundamental of YOLO basically CNN. So if you understand the CNN, you can understand the YOLO, how the YOLO working. Okay. Okay, let's move forward to the CNN. So what is CNN basically? Okay, convolutional neural network or CNN basically has three layer. Okay, three layer. So the first is convolutional and ReLU. So convolutional and ReLU can be one component basically, or here you've got two components. It's okay. So convolutional, and then you got ReLU inside the convolutional, and then you got pooling, what we call pooling, and then you got here is pools and neural network connectivity layer. So this one basically what we have learned just now on the previous lecture. What you have learned from the previous lecture is this one, exactly the same. Okay, exactly the same. And when you have neural network, you put convolutional at the beginning, so it becomes convolutional neural network. So we're adding more to item here, and this is the neural network that we have learned on Fashion Minutes, exactly the same. Okay, so the input will be image, move to convolutional and ReLU, then go to pooling, then go to fully connected neural network. The advantage of neural network basically let me see. Okay, this image. Okay, so basically what you see here, okay, this is what you have machine learning. Okay, you got the input, then you need to do a feature extraction, and this is the most tedious work. Okay, in case you have a customer, bank customer, you already have feature extraction where you got customer number one, age, salary, address, monthly pattern, other debt, credit card, and so on. So you got at the column there features. That's okay. But for the image, if you want to do feature extraction, you need to extract it. The age, the color histogram, everything. So it is a tedious work. Then you can put in to the classification. But with neural network, as you can see just now, So these are on image. You just flatten the image end by end into pixel, row of pixel, and then just put into the neural network. That's it. You don't have to do feature extraction. Okay, and this one. Okay, so you just input this one. This is another representation of images. 28 by 28. You flatten it into one row, one column, 1 to 70. This one, then you just insert into the neural network and put the class label, then they can learn. But in case of without deep learning neural network, without deep learning, you have to do a feature extraction. So this is the most cumbersome work. All right. So if you do HVM, KNN, decision tree, you have to provide the feature extraction. Okay. And when you're moving to neural network, also called deep learning, you don't have to do a feature extraction. So that's the advantage of CNN neural network. All right, just moving back here. Okay, so convolutional. Okay, we move to the first component, what we call convolutional. So what is a convolutional basically? So convolutional process basically it is a convolution sum. In other words, we use the mask shown on the right. So this is the mask topic, the mask. Okay, so it's centered at the level PZ5 shown on the right. Pixel marked by do not take part. Okay, so you got a mask here, topping, mask, and this is the image. Okay, so the input image, and this is the mask. We need a mask, and this mask is 3 by 3. Okay, and this is the image. You got row and column. This is called pixel. 5 by 5. You got 25 pixel. Here you got 3 by 3. You got 9 pixel. Okay. So what we do, take this mask on top of this one. So you got 3 by 3. You got 3 by 3, the same. Okay. So you got 3 by 3, the same here. Okay. So this is 3 by 3 mask. You just put on top of the image, overlapping. Now what we're gonna do is just do this on the mask and the input. So what we're gonna do is just do this between the mask and the input. So you got 1 to 9, and you just Z1 times in the pixel of the image plus Z4 times to the pixel of the image. Okay. So W is this one. Z1 is basically this is a Z1, Z2, Z3, Z4, Z5, and Z25. Okay. So what you're gonna do is just this Z1 W1 times Z1 plus W4 times Z4 plus W7 times Z7 plus W2 times Z2 plus and so on until Z9 plus Z9 times W9. So you use this formula basically. And this is for example. So you got image, you got filter. So mask is also called filter, the same thing. Okay, so this is filter. Okay, so when we said filter, mask, it's the same thing. So you got 3 by 3, and you fill in the content here, 0. So you put a content like this in the mask. It's up to you. You can put any content here, whatever content you can put here. And this is the image. So each image has pixel basically, value depending on the image. So what you're gonna do is, so this gonna be overlapping here. Okay, all right. So then what you're gonna do is you move this 3 by 3. So this is 3 by 3, the same. filter. Okay, this one. So the next step is that you just move to the left, to the right, one pixel distance. Okay, and then now it's here. Then the next thing you're gonna do is you move to the next. Okay, so the boundary here must be not over limit. It must be the same. Then after this, you move here. Then next you move here. Then next you move here. Then next you move here. Next you move here again. And lastly you move there. Okay, here. The last one. Okay, so you're gonna do from the beginning there and repeat back again until the end. So you're gonna do that. That's mean convolutional. And so what you're gonna have is like this. Okay, remember the following this. You back to the original now. You got filter and you put it in here. Then what you're gonna do is do this. 1 plus 1 is equal to 1 plus 1 plus 0 equal to 0 plus 1 plus 1 equal to 1 plus 0 plus 0, then you got 0. 1 plus 1, you got 1. Then here you got 0. Then here you got this one. And this one, you got 0, 0, 0, 0, and 1, you got 1. At the end, you got 1. So you got 1, 2, 3, 4. So you got 4 here. So that's the way how you do it. Then you move to the next, the same thing. Okay, so 1 plus 1, 1. 1 and this 0, 0. This 0 and this 0. 1 and 1, 0. 1 and 1 plus 1. 1 and 0, that is 0. 1 and 0, 0. 1 and 0, 0. 1 and 1 plus 1. So equal to 3. There you got 3 there for the next. And then for the next is the same thing here. You will get 4. So what you notice here, you got 5 by 5, you got 3 by 3, you got output 4 by 4, 3 by 3. Because you only move from the beginning, 1, next, only 3 moving. So you got 3 by 3, okay? So the size, output size will be smaller. So remember, this is the image input, this is the filter, and this is what we call features, convol features. All right, that's convolutional, basically the term convolutional. And input is 5 by 5, filter is 3 by 3, size of the output is decreased. So you can use this formula. N is 5 minus 3, 2 plus 1, 3 by 3. Okay, all right. So this is about the image. Okay, so if you got one channel, okay, you just only got 1, 2, 2, 5. Okay, so one channel color. Okay, so you got 1, 2, 2, 5, 5 color. So basically A and B is A is considered column and width. Channel is basically is the depth. Remember that depth or channel is the same thing. Okay. So one is I think it's metric BB and depth. Okay, channels is equal. So depth here. So this here this is 3. Okay. So this is 3 channel basically because you got 3. If we got one like this, so this is 1 channel. So this is 1 channel, and these all are 3 channel. Okay, remember that to visualize the term channel and depth. Okay, so you got depth by width by height. So the image is really visualized like this. So the term width, height, and depth. So depth is basically the channel, the same thing. And okay, all the same thing. And now is a grayscale. This is a one channel color. This is one channel grayscale. Okay, which is a 8-bit color, and this is a 8-bit grayscale. Okay, the same thing. This is 8-bit color. This is 8-bit grayscale. Okay, and so this is how computer C operate the image. And all right, so this is the visualization animation about the thing. So you got image, you got 3 by 3, then you got output. Then what you need to do is just moving forward, okay, just moving, okay, and so on until 3 by 3, until 3 by 3. Okay, until there. So you got at the end here, right there about this one. All right. So in this case, we're using this, okay? Remember, this is the formula. You can have many formula, but in this case, we use this formula. Okay, convolutional sum. Okay. All right, and this is the visualize, and this is also another to visualize. Okay, so if you got 32 by 32 images, one channel, 32 by 32, one channel, and you got 5 by 5 also one channel. So this and this must be matched. If you got one channel, you also use filter one channel. All right, and so this is one channel. If you use this one channel, this also use one channel. Remember that you got 5 by 5. So this is 5 by 5. Okay. So this is all right. So if you got 5 by 5, 5 here, and you got 5 here, then you got 32 by 32. Then that's mean you got you use one channel and must be follow one channel. So you got 28 by 28, also one channel. Okay, also one channel. This is important. For 28, the size is smaller based on the formula just now. Okay. Now remember, if it is one channel, the input is one channel, the filter must be also one channel. All right. Okay, so now if you got 32 by 32, one channel, then you can have 6 filter. Okay, 6 filter. If you got and if you got 35, then you got filter 5 by 5. Okay, so you can do 6 times. You can have 6 filter like this. So if you got 6, you got here 6. Okay, and this is become 28 by 28. So this is what we call convolutional features or activation map. So remember the term map. If you see the term activation map, mean it is a result of convolutional. So if I run through another 10, 5 by 5, so you're going to have 10. You can run this again. If you run again this one, 5 by 5, okay, you run again this is on this. With 6 filter, you got 6 channel and column and row. If you got this 10, so you're gonna have 10 channel, and you got 10 channel, and so on, and you're gonna have so n minus f plus 1. N is 28. So put 28 minus 5, 23. 23, so this is 24 by 24. So the size becomes small. So this is a concept, you know. When you do the implementation, we don't do this. We use Keras, simple, okay. We just do the conventional. The Keras will do the same between a few lines. But we need to know the detail of the process concept for research base and something like that. All right, and so if we got 24-bit color, so this is a 3-channel, okay, RGB. So you're gonna have like this, okay, RGB. So this is R, so this is G, and the last one is B. So 3-channel RGB. Then the width and height will be the same. Okay, so you got 3-channel, 1 R. So this is the second is G, and the last one is B. Okay, so it bit hassle, you know, the convolutional neural network. Okay, now this is how the 3-channel. So you got 3-channel this R, G, B. So 3-channel. When we say 3-channel, mean RGB. Okay, remember that the word channel. When we say 3-channel, mean RGB. Three depth. Okay, and so this is R, this is G, this is B. And what we do is we just do the convolutional. You got this plus all this. You do convolutional this and this, you do, and then you got results, and then you got this and this, you got result, and then you got, so you need 3-channel also, 3 filter. So then sum all. Okay, so when I move just like that. Okay, so this is this one, this on this, 1 filter each. Okay, then when you calculate sum here, convolutional sum, you got 318, you got negative, so you plus total up, you got 25. Okay, plus 1 is a bias. If we can have this, then you got put it here, the result. Then for the second, you just move to the second. Okay, so the filter is still the same, and you do the same, plus all, you put next. All right. So here you got so many questions. What if the filter got different value? You can do some research there, you know, investigating the role of filter in convolutional. Okay, but so far they use the same fixed filter for the whole thing. Then it move to the next. You can go for many channel basically, but just limited to 3-channel because we got RGB. Then we move to the next and next. Okay, and this one is what? It's many channel. Okay, if this one is the input is 3-channel RGB, so you got R, okay, RGB. Okay, so the filter must also be 3-channel, the same, follow the same, and the size will be reduced, and the output is 1-channel. Okay, remember that. Okay, so it's a bit complicated and too many things. Okay, and if you got 6 filter, you do filter, you got 5 by 5, so you got 6 channel and 28 by 28. Okay, activation map. All right, so if I do the same, you got 10, 24 by 24. Okay, you got 10, 24 by 24. Okay, you got 10. So you got 10, 24 plus 24. You got 10 here. All right, and okay, let's move. All right, so strike. What is strike? Basically, strike is, look at the yellow. This one. Strike mean you jump 2 points. So this strike 1 mean you just jump 1 point. So from there, from here, you move only 1 pixel. Okay, you just move here. you move to the right 1 pixel. Okay. Now strike 2, you got here, so you move 2 pixel. Just now you there, so now you move here. Okay. Just now you are there, now you are moving 2 pixel. That means strike 2, and so on. So when you got strike, the size also different basically. So in this case, become 2 by 2, strike 2. If you got strike 1, so you're gonna 3 by 3. Okay. If you got strike 1, you're gonna 3 by 3. And if you do strike 2, is 2 by 2. Right? Can you do the strike 4? Strike 3? Double? 3? You cannot because tidak terlebih. Okay? Alright? So you cannot use that. This error. Alright, and strike. So this is strike. Padding. Padding basically you. So in this case, you got 3 by 3. Okay? Alright? Remember this? This is the convolutional. You got 5 by 5. You got 3 by 3. So when you convolutional, you got this is 104. When you move to the next, it become 99. Make a cube to the next is 0.3. If you put like this, you got 3 by 3. This is 5 by 5. So this is 3 by 3. Okay. So the output is 3 by 3. The input is 5 by 5, but the output is 3 by 3. You lost 2 columns here. This one and this one. Okay. It's supposed to be 5 by 5, isn't it? If you want to be 5 by 5, so you need to put there. So here you can adding more column and row at the outer border. Then you just put 0 in there. All put 0. And you can do like this: 3 by 3, 3 by 3, 1, 2, 3, 4, and 5. So the output you're gonna have by 5. You see, your input is the original is this one. This is the original input. When you do padding, you put extra column and row at the outer of the image and put 0, so that when it do the kernel 3 by 3, it produce the same output. So this is 5 by 5. 5, and this also, the input also 5. Okay. Remember, the output is 5 by 5. When you do 3 by 3 filter, the output is 3 by 3. Then you need to put extra here, column, row, so that the output will be the same, 5 by 5. Okay, so that's the purpose of padding. Strike, padding. Okay. So in this case, then you can. Okay. All right then. So this is just simply, you got the 39 by 39 by 3. And you use filter. What is this? Strike is 1. Padding is 0. You got 10 filter. Filter is 3 by 3. Okay. So when you do this, you got, okay, 37 plus 37 times 10. This is the output you got here. 37. So this is 39. 39. So this is a concept, you know. If you want to do research, you have to know this one. So 3 by 3 filter, so it becomes 37 and 37. Since you use 10 filter, so you're gonna have 10 channel here. So that's why you got 37% by 10. And here, if you use 20 filter, now you have used 5 by 5. Okay, now you got 17 by 17. See, almost cut half. If you use 5 by 5 to this one, then you got 20 filter. So you got 20 here. You got 20 channel, and then you got 17 and 17. Okay. Now you understand when you use, how many filter are you going to use? Remember that the size filter is important because of this. If you use filter bigger, the reduction of 37 by 37, this one is 37, 37, and you got 10 here. Now 37 becomes 17 to 17, and you got 20 channel. You got 10 channel here, you got 20 channel, but the size now becomes 17 and 17 from 37 to 37. Okay, so it cut half, 37 to 17. Almost you're gonna cut it 50% from the original. Here 39 by 39, 39, 39, and you got channel 3 RGB. Then you use 3 filter. You got 10 filter, 3 by 3. So you got this output 37, you got 10 channel. Then here you use 5 by 5 filter, and 20 filter you use strike 2. I think this is because of strike 2, because you have strike 2, so it becomes 17 by 17. It probably because of the strike 2. Okay, not the filter, the strike. Now this is strike is 1, this is strike is 2, so it moved 2 pixel. Okay, strike. Remember, strike is you move 2 pixel on the right. This is you move the filter 1 pixel. This is you move the filter 2 pixel to the right. So it becomes small. And this one, if you run to the same 5 by 5 filter, striding is 2. So strike 2 make it cut into half, becomes 7 by 7. And number of channel is 40. So this is open for research, you know, because the number of this could be many. Could be many reasons why you doing this. What's the purpose of using 20 filter, 10 filter, size of the image? Okay, so now you understand when you're using size filter is matter, number of filter is also matter, strike either 1 or 2 is matter, padding is also matter. If you want to remain the same size, probably padding, you use padding, right? You use padding, then 39 here become 39, and then he become 39, he become 39. So use padding. Okay, so this is the way how you look at it. Okay, and other than this is extra, you know, extra. So basically you got filter, you know, you got filter. This is 3 by 3 filter. Okay, and if the filter you fill this number, it becomes Sobel filter. Okay, and if you fill your filter with this number 310 3000, it becomes scarf filter. And if your filter you put this number 3 by 3, you fill this number, you're gonna have this image. If you use this number, you're gonna detect the age. So these are specific numbers you have to use for the age detection. So if you run this convolutional and using this filter, the number content of your filter is exactly this number, you are proceed into the age detection. If you want to sharpen your image manually, then you can use this filter. When you use this filter, so this is the original image, then you can more sharp here. See this? More sharp. Right? So you can use this filter. And if you want to make a blur, you can use this filter. And if you want to put a Gaussian noise into your image using this filter, then this is Gaussian. You got a noise called Gaussian blur noise here. All right. So these are some of the concept of convolutional neural network. Okay. The convolutional basically use filter. It can be used many ways. but we can use convolutional in neural network for specific tasks. Okay. So your filter not exactly like this in convolutional neural network. Okay. So inside there in convolutional network you got filter. This is considered weight. You're gonna use the optimizer to update the content of this filter in convolutional network. All right, if you use this filter, Sobel filter and Ska filter, so you got, if you use Sobel filter, you're gonna detect the vertical. So all the vertical here, you're gonna detect. Napes filter. They're gonna filter this image, only output is the vertical. If you use the Ska filter, it only detect the horizontal. Okay. So this is edge detection. So if you combine both, so this is features, you know, this is called features of the image. So if you use a Ska filter, you can, the output will be only the line. So if you combine both, you can have both into one picture. Okay. So the content here is important for the convolutional network in general. Okay. So how do you get this content? They do some experimental work, try many numbers. At the end of the day, they come out that this is the number for horizontal. Okay. So if you can put a filter, pre-filter for the curve, circle, that's good. Okay. All right. So these are the. So you got image one here, and then you got five by five filter. 32. You use 32 filter. You use 32 filter. 32 filters. Okay. You use 32 filter. Each is 5 by 5, and this is the image you want to. This is the input image. When you do convolutional neural network, you got 32 activation map. So this is some sort of channel 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So remember this one? So you got 32 here because you use 32 filter. And if it is 28 by 28 pixel, like a fashion minis, so if you use 5 by 5, basically you're gonna have, I don't know, 24 by 24 probably. Okay, you have to calculate there, f minus n minus f plus 1. And if you do strike is equal to 2. Maybe this is cut into half. Maybe it's become 15 by 15, 14 by 14. If you, so you got image is here is 14 by 14 basically. And since you use 32 channel, means that you're gonna have 32 channel here. Okay, so you see this is what we call features. All right, our eyes cannot differentiate this. Let the neural network model differentiate this into according to the label. We don't understand what is all, but investigating this is very good research topic. Okay, so today people still investigate to understanding these features. What does it mean basically? Can it tell something about this? You know. So at the end of the day, we know that the model decide to be this level because of the features is like this. We can explainable. Okay. Otherwise, we cannot explain. Neural network is just a black box. So if we can investigate this, probably we can know something what's happening in the neural network learning. Okay, the activation function. So basically, it's just a ReLU softmax. Okay, it is simply the output you got. It just this is ReLU function. See, this is fx. This is the output of the function. Okay, and this is the input. This is mathematics simple. If x is 4 here, 1, 2, 3, 4. If x is 4, then the output will be 4. Same. Okay. So you got 1, 2, 3. If the output is 3, so 3 the output. If output is 4, the output is 4. The same as it is. If the output is negative 4, let's say here is negative 4. Negative 4 is here. Negative 4. Okay. If x is less than 0, okay. If x less than 0, negative 4 here. Here is negative 4. So the output will be 0. So if the input is negative 2 here, x, so the output will be 0. So in other words, we're going to eliminate all things below than 0. That's the ReLU. That's what we call ReLU function. ReLU function basically is just to eliminate all negative value. Simply like that. That's the purpose of ReLU function. Activation function called ReLU. The purpose is just to eliminate all negative value. Only remaining positive value. So that's the purpose of ReLU function. That's why people use it, ReLU function. So you can create your own activation function like this. So all negative value will be positive. All right. You can modify your activation function. So you can say ReLU whatever here, so like this. So whatever is here, it is positive. So here the ReLU just put all value below 0 become 0. Now here when you got like this, when you got put like this function, you can put all negative into 4. So if you got negative 2 here, so here it becomes 2. If you put ReLU, negative 2 becomes 0. All right. Okay, so this is removing all the negative value. Okay, that's the activation function. All right, and the same thing. Set 0.7, it become the same because this indicate ReLU. Okay, function ReLU. So this negative becomes 0. So this is become 1.1 and so on. Okay, pooling layer. Pooling is simply cut size into half. That's the purpose. Pooling means cut anything into half. So it's just convolutional. This 2 by 2, put it there, 2 by 2. Okay, and the next, you're not moving here, but the next you are moving here. So the third one will be there. So it's just like strike 2 lah. So the fourth, so it's not overlapping. It's just so it cut into half then, and then you can take the maximum number. If you take the maximum number, so the second part, the maximum is 103. So here is 104 maximum. The maximum here is 104. Here the maximum is 103. You can put the maximum only. So in this case, because this is the content of the pixel, probably big value means something. Here you got 101, and here the largest is 106. Okay, so now it cut into half, more than half. This is 4 by 4, 5 by 5 into 2 by 2. All right, that's pooling. Pooling layer is cut into half. All right. So in this case, you use max pooling. If you use max pooling, you take this maximum. So you got 2 by 2. The full filter is always size 2 by 2. You got 2 by 2 here. Then the next you got strike 2. Yes. Not overlapping. And then the third moving here, and so on. So here, if you use max pooling, so you take the maximum 3. For this one, take the maximum 5. Here you got take the maximum 7. You got 7. If you use max pooling, if you use min pooling, basically sum up all together divided by 4. So you put it there. Sum up together, average it, and put it there. If you use sum pooling, basically it's just simply 2 plus 3, 5, plus 2, 7, plus 1, 8.5. So here you got 8.5. Simply like that, okay? Alright. So there must be a reason, okay? As long it doesn't affect much the original content of the photo. Probably they have checked it out there. So it reduces the dimensionality to focus most important element. And here, if you use max pooling, you are really expect that the bigger value of the pixel is the most important element. Okay. And okay, if I have 6 by 6, go through 2 by 2, what are the size metric of the output? Anyone? Anyone? Who still can follow? Otherwise, you can read my video lecture later on. I need to finish the video lecture so that I can post it to all of you. If you feel tired, you can stop right away. It's okay. So anyone 6 by 6? If I go through 2 by 2 pooling, what are the final size of the output?
3 by 3.
3 by 3. Yes, thank you very much. Who's speaking there?
Me. Is me.
Huh?
Wenhua.
Okay, thank you. So 6 by 6, 2 by 2. So this is a dimensionality reduction. Okay. Good. And so now you are able to understanding this picture. Okay, you will see this picture as very on internet. Now you'll be able to see this. You got 128 by 28. You got 3 channels here, RGB, and the size of the image is 1 to 8 times 1 to 8 column and 1 to 8 row. And here they use 40 filter. Okay, they use 40 filter, and they use ReLU and pooling here. So 128 becomes 64, half of the size. So he using the pooling layer cut into half. Okay, the pooling layer cut into half, and you use 40 filter. And then here 32 by 32 again you use a pooling filter, and this time you're using 80 filter. Probably 3 by 3, 2 by 2, 5 by 5. And now he used another 300 filter. It cut into 16, or it cut into half, so that it has a full filter, pooling filter, basically. And probably they use the same padding, so that the size will be the same. Then they cut into half. And now he used 800 filter, and it's still using a pooling filter to cut into half. From 16 to 16, it cut into half into 8 by 8. Now he used more filter, 1022 filter, and now the size is become 2 by 2. All right, so it's more than half. So he also used pooling filter. Also, they affect the stripe and the padding as well, because it cut into it more than half. Okay, so the rest is just tutorial. Okay, and this one is okay. So I think this is the most important thing you can understand when you have this on the internet, on any paper. Okay, so this is convolutional neural network basically. So at the end of the day, you got this, and from here, then you move to neural network, what you have learned yesterday for the past few weeks. Okay, before Raya itu hari. Okay, and this is tutorial layer 1, layer 2, and so on. Okay, I think this is straightforward. I've told about now this is use 6 filter. This is 6 filter, 5 by 5. So filter 5 by 5, strike 1, strike 2, and so on. So they don't have pooling layer here. Okay? They don't use pooling filter. Now fully connected layer. At the end of the day, this one you just flatten it. So you got all are flattened, not by 7 by 7. You got 1960 row and one column. This is 7 by 7 by 40. This is 1 by 1960. Okay. Now here you just like fashion finish. Treat like a fashion finish. You got 1 up to 784, and you just move here. Put the label. What is the label you have, and so on. So these are the same like what we have before Raya. Okay, what we have done on XOR, operation, and fashion finish. These are applied the same. So the important is this is also the same. This is also the same like fashion finish. Okay. The important is you adding extra this one. This is quite challenging here. Okay. And the purpose here, I want you to know the concept. Why is happening like that? Why they do that process mechanism, filter, pooling, and so on. If there is any other method, yes, you can put other method if you like, and you have to prove it. The method is good. All right, and this is also a tutorial. This is LANet in 1998. This is the architecture of LANet. Now you can understand the LANet. It's in what year? I can't remember. 1998. It has how many convolutional? 1, 2, 3, and 4. So the first input is 32 by 32, and it is one channel. You use filter 5 by 5, strike 1. You got the output here, and you use 6 channel. When you use 6 channel, so this LANet basically use 6 channel, and then they average the full. So the pooling filter they use average, not maximum. Okay. So when they average, okay, so he got 14 by 14 cut into half. Use pooling layer, so 28 cut into half. You use 6 filter, and the size of the filter is I think same 5 by 5, and no, the size of filter is 2 by 2, and now we use strike 2. And later on you use 5 by 5 filter, strike 1. They use 16 filter, and it don't have pooling layer, pooling filter. So the size reduced a bit to 10. Now here they use a pooling filter, the size cut into half, 5 by 5, and they use 16 filter, and now filter is 2 by 2, and strike 2. Padding, no padding, okay? So at the end of the day, you got 5 by 5 times 16. How much? 20 kali 16. So 5 kali 5, 25 times 16, you got 400, isn't it? So you just flatten 1 to 400, isn't it? 5 by 5 times 16. Just let me calculate, okay? 5 times 5 times 16. Okay, 400, okay? Instead of 5 by 5 by 16, you got 1 by 400, 2-dimensional. This is 3-dimensional, you change into 2-dimensional, into 400. Then this is just like fashion finish. And this LANet 5 in 1998, it used 2 layers. The first layers is it used 120 small, and the second layer it used 84 nodes. Okay, and this is the class label. So you got convolutional, pole, convolutional, pole, and fully connected. XC is fully connected neural network. All right, this is a LANet. And this is AlexNet. If you remember AlexNet 2012, I remember who make it somewhere there. So it's a bit more bigger. You can, and then it's got parameter 60 million. So how do we know the parameter? It is about the filter. If you got 3 by 3, you got 9. Okay, and then other thing as well. Okay, so here you got working on image 227 by 227, and it is working on 3 channel RGB. So this is working on 1 channel. So this is working on 3 channel, and it use filter 11 by 11, and then you're gonna strike equal to 4. You're gonna make it small size, 227 up to 525, and it is 96 filter, and so on. So this is the architecture of AlexNet. Okay, and you can use this model. The weight, everything has been saved. The model, you can use it. Okay. So this one is VGG16. It's more complicated then. Use convolutional as well. How many convolutional? This is twice. This is twice. 4 already. 4, 7, 7, 10, 10, 13. 13 convolutional. That's a lot, you know. So we need GPU then. Okay. Our friend coming is working out with CUDA, CUDNN. I'll post it later for those who are interested. Okay. So it is a bigger network. The number of parameters also 138 million. So we are dealing with. So here you got 13 convolutional, and you got how many? 64 filters. 64, 128, 128 plus 128, 300, 356, 356 plus this 300, 356 means 600 something, 600 something plus another 300, 900, 900 plus 1000, 1500, 1500, 2000, 2500. So you got 2500 filter use. Yes, coming CUDNN. Coming still working on CUDNN. How to install? You can check your laptop. If you got GPU, you can use CUDNN to accelerate the process. If you're working on this, you know, here you got how many just now? 2000 filter. All right, and you got 2 layer here. At VG16 got 2 layer. The first layer you got 496 node. The second layer you got 496 node, and he provide you with 1000 label. You can fill in. Okay, so it depends on what data set you use. If you use a vehicle data set, you can list down all 10 vehicle: lorry, bus, car, bicycle, motorcycle, and you have to provide the data set and use the same model here. Then you can do some prediction, save your time. You don't have to try and error using the VGG16. Okay, it's already made it. I think it's from VGG16 is from the Microsoft, I guess. Okay, Microsoft team, Microsoft Office, all those their team. Okay, so all right then. Thank you very much.